Good morning. This talk is Mitigating Ransomware Attacks at the Block Level with OpenZFS. My name is Michael Dexter and I wear a number of hats, but if you caught my last talk, it was about my work with the SNIA DPCO, the Data Protection and Capacity Optimization Working Group. And if you haven't seen one out there, the new edition of the SNIA dictionary is out. I am glad that the DPCO has been able to review and add a few terms, and you'll now see basic OpenZFS terminology in here, which is a step forward. And as I mentioned to the last group, I invite you to reach out to the editors of the dictionary if you find that a definition is dated or miscategorized, or if you have something new to add to it. They've been very responsive, and we should keep this as the definitive storage dictionary. So the topic of the hour, what is ransomware? The working SNIA definition is a type of malicious software or malware that prevents or limits users from accessing their system, applications, or data, or alternatively to publish the user's data unless a ransom fee is paid. Now, that has been a concept out there for a very long time, but has recently been a rather hot topic. For the purpose of this, let's consider ransomware any form of ransom, be it the encryption of data, be it the unauthorized publication of data, be it the exfiltration of data, which I think is something we'll see more of, or data napping, if you will. And payment for that data can take many forms, be it Bitcoin or premium SMS messages. And typically, a ransomware attack starts through phishing bait, which is a bit of a slang term there, of attractive junk email that includes the malware. And increasingly, various malware is being pushed by advertising networks, unfortunately. I'll go through the absolute classic ransomware scenario, which is a bored user on a Friday before a long holiday is rummaging through their junk email box or otherwise and clicks on something problematic. Now, the truly problematic aspect is that on that Friday, they could be gone for a week or a month, depending on the holiday or the nation and its traditions in holiday length. And the malware will begin encrypting, and that could be a slow process. And if that encryption or other nefarious activity takes place while they're gone, it's typically when the system administrators are gone, such that they as a user may not notice it and the administrators may not notice it until it's too late when they all return. So I'll touch on later about the various windows of opportunity that one needs to think about. Now, the reach of ransomware, obviously popular file types, let's just say starting with Office documents, but the reach is getting quite clever into network shares, online backups, the slang term is shadow copies, but various document revision systems, and cloud accounts like Dropbox and the like. And maybe you have good examples of other ones that are on the roadmap there. But keep in mind that if a user is accessing data and it's backed up, that malware can travel with that backup. And that's where it gets partly concerning. And above all, and this is the one slide I want you to leave home with an understanding of, this type of malware is nefarious in its simplicity. It is indistinguishable from the data deletion by users. If they were to delete data with their own user permissions, this is essentially no different. There is a cat and mouse game trying to mechanically identify the behavior of any such attack, because the attacks come in so many forms. And there's a pretty bad history in this industry of people doing concept malware, such as the Morris worm long ago. But I believe a shell script could use about 4 commands to move data off to an available share, mount it in advance, or maybe just over the web, and write the ransom note of where to find that data. It is wickedly simple, in its potential reach. So, above all, this type of ransomware is typically self-inflicted. There's virtually no hacking involved, and that's the key point. The fact that it's using user permissions over their own data or shared data that they have write access to is fair game for this type of malware. It is no different from a user just deleting everything they have access to. And where that can go is, well, deletion, which in many regards is less damaging than the sharing of data. It depends on the nature of your company. But looking at the recent data breach involving U.S. citizen private information, deletion would be preferable to what took place there. It may harm the business, but not from a functional perspective, but not from a legal perspective. So just keep in mind what simplicity is behind this. And if you look at various mitigation strategies, as I put in quotations, just update your antivirus software. Well, write access is the primary attack vector. And from a traditional Unix computing environment, well, sudo access is requiring a password to do a certain thing. To truly mitigate this, you would need a user to provide a password to pretty much write to any file, and naturally users would not appreciate that. I generally prefer things be on-prem, but web applications in fact do offer a certain level of protection from this. But again, things like Dropbox and such that are increasingly integrated with the desktop, the moment that desktop has write access, it is potentially fair game. And those attacking generally have time on their hands, and with something as simple as write access being the criteria, it's very simple to come up with a new attack, and as simple as a shell script, as I mentioned. I did a quick informal poll on Twitter, and a few respondents said, hey, yes, we've seen server-side attacks. Now, I'd argue in a Windows environment with the primary targeted workstation being Windows-based, if you have common ABI, if that malware is stored within the system and the system administrator gets bored on that Friday before a holiday and starts rummaging through executables, as they probably shouldn't be doing, they could subject their back-end systems to such attacks of the various forms. And I will argue that restricting write permissions is about the only thing you can do when write access is the attack vector, but naturally that has its major challenges, and especially from a user's perspective. Now, various tools look for warning signs of such activity. In all practice, if one were working with an array and had zero awareness of such malware, there's a very good chance if they are using snapshots, their volume would fill up with copy on write data, and you would simply wonder why it's full as it's encrypting data that is hopefully in an unencrypted state simultaneously. We'll get more into opportunities there. But naturally, if we're attacked, we'd see rapid encryption activity. Well, the moment you mitigate that, the attacker will slow down their activity. Maybe file by file, maybe in a random pattern, and that's a cat and mouse game. One could use your operating system's provided tracing mechanism to look for certain behavior. I suppose there's a reason to use each of these strategies in some way, but naturally you're trying to guess what's coming next, and that's always been an arms race. And again, you could watch for data exfiltration. If a large amount of data is exiting from a given user, that could be a sign, but you might be attacked by a number of factors simultaneously. So this is most discomforting in the simplicity of it and the potential reach of it. And so I personally have hands-on experience with out-of-band, if you will, mitigation at the block level. This is system administrator territory by definition. It's what resources are maintained behind the door with the glass window and then provided to the users once they beat through that door. And naturally, traditionally in storage, anything at the block level is the domain of the system administrators and is provided to users at the file level. So the role of the super user is important here. And that model hasn't changed in a very long time, so it's quite familiar to organizations of all sorts. And I would argue this can be done in a rather file system agnostic way, although every file system has its advantages and disadvantages in this regard. And everything I'll discuss can take place inside your current storage stack, rather than adding on a piece of software, adding on a new piece of hardware, adding a middleware to mitigate such issues. So a key fundamental strategy I'm discussing is block level versioning, and doing that through snapshotting. And a user who is potentially the guilty party in allowing attacks into the environment would benefit from an undo ability that's, in this case, actually outside their control. Because when it's inside their control, things like shadow copies in the Windows environment can be equal fair game for such attacks. That maintains a strict administrator and user distinction, and as organizations get more equipped at a smaller size, we have to be very conscious of that. Even if you are that user and administrator, do separate your role as an administrator and your role as a user. If it's an undo, ideally it's non-destructive. Restoring from backup is rarely a great solution for end users, because they could have done any amount of changes since the long ago prescribed backup strategy was presented to them. And ideally it's fine-grained down to the user level, such that I trust, if you all maintain users, there are certain ones that are more guilty of making mistakes repeatedly than others, who hopefully make the mistake once and learn forever. But it varies. And above all, any strategy requires a clear and coordinated restore point objective and restore time objective, and I'll touch on that in a little more depth now. So the RPO and the RTO. Now, as for restore points, well, what point in time can we go back to? That means a lot of different things to different people. To some people, it's down to a matter of seconds or minutes. To some people, that's by the day. Some folks only care about hourly or daily increments. It varies, but communication with your users is key. As for the recovery time, well, as I give an example, admin, teacher, help, I deleted all my data. What time does it take for someone to pound on that glass window door and resolve the issue from both the administrator's side and the user's side? So for some, that means a very clear SLA, because those may be paying users that you've never met in person. And then naturally, does your infrastructure allow the scaling to meet the needs of many paying customers to be hit by the same attack simultaneously, which is probably, thanks to Murphy's Law, not at an opportune time, be it the attack on a Friday before a holiday. Even though you have a solution to the problem, you want to be done with that challenge and move on. And in looking at this, I think you'll find many benefits beyond ransomware mitigation. The communication between the needs of users and the abilities of the system administrators is a very good thing. I'll consider ransomware the motivator of the hour, as I put it, and this all assumes that your file system is capable of snapshotting in an efficient, meaningful way. Some do it well, some do not. For example, the classic UFS file system that came out of the BSD arena in Berkeley does have some form of snapshotting, but it is not super efficient. It's not intended for, say, per user, per directory, hour-by-hour snapshots. And GNU Linux does have LVM snapshots, and I have not worked with those. The Dragonfly BSD Hammer FS has its own notion of snapshots. ButterFS has a notion of snapshots in Linux. That's also a hot topic this last month or so. NTFS on Windows does have its own notion of volume snapshot service and shadow copies, and I did touch on that earlier about when the user has the ability to go back in time through the VSS, they can do damage through that. So be very clear on having what's considered a good feature and controlling access to it, be it from the administrator's perspective or the user's perspective. And naturally, Waffle and Oracle ZFS have snapshots, sometimes with limits such as the number of snapshots, and some perform well as you increase in snapshots, some do not. So as I point out here, for some file systems, snapshotting is a bolted-on functionality. Again, it can have performance impacts. It may not. Some are fine-grained, some are not. I'm just recapping. And there are very few solutions that are desktop and server agnostic. A SAN filer might not have the same file system you can run on your desktop system. And I think the importance of these challenges warrants considering your flexibility there, so that the same infrastructure can serve literally end users and the centralized services. So that brings me to OpenZFS, which has from day one offered institutionalized snapshotting. And for those not familiar with it, it's a copy on write file system. Most file systems are overwriting traditionally, whereas if you want to update a file, you overwrite it with the new file. And if that process is interrupted, you have a problem. So OpenZFS and most copy on write file systems write to disk and dereference the previous copy, which is a safe operation, avoids, I believe it's the RAID 5 write hole and other challenges. And as a copy on write file system, all writes are organized into transaction groups, which are all in a long line. And that inventory, if you will, or index of writes creates a great many opportunities, because you have a journal, to use traditional terminology, to veer from that and, shall we say, fork your file system at any given point. And that allows for pretty much a universal opportunity to snapshot data at all levels, be it at the file level and block level. And stepping back, all new data that in the snapshotting is a delta of the existing data. So those snapshots are very efficient. And regardless of what file system you're using, I hope it does those really well. And so when this ability is available of institutional snapshotting at near zero cost, you can drill down to snapshotting data at the individual directory level, at the top level of any given storage array. There are writable snapshots in the form of clones, which very much in a ransomware attack situation, there's reason to preserve the infected state, yet provide a previous state to your users so that you can engage in any forensics or potentially a search for what data potentially changed between the good snapshot and the attacked set of data. Internal to OpenZFS, one can promote a snapshot to an independent file system with its own set of blocks, allowing the destruction of the first chain that got you there. So it's very flexible in that regard. And the snapshotting provides a foundation of OpenZFS replication, in which, as a file system that is checksumming your data at every stage, by transferring those efficient deltas of changes to another system, you have a pretty much guaranteed duplicate that is audited, if you will, insofar as the data has been checksummed through the entire process, and you know you are maintaining synchronized not in the mechanical sense, but identical snapshots of the source and the destination. So you are pretty much guaranteed to be identical up until that point of that snapshot. And that's, in many regards, a very good thing. Now, specifically in OpenZFS, I don't want to get too deep into the mechanicals, but it uses a Merkle tree in which any block of data contains a snapshot to a child block of data. And a certain very popular early copy on write file system from a storage vendor keeps the checksum data with the block in question. And as I believe Jeff Bonwick put that in his original ZFS presentation, that creates the UPS problem. Here is your package. It is in perfect shape. It's not my package. Well, it's perfectly intact. It is unmangled, but it's not mine. So it does take that structure of that chain of trust, if you will, to say that a third party, if you will, is verifying that that is yours because it is apparent to that block. So that's, I haven't seen a brutal either attack against that, but any form of metadata data level corruption could in fact leave you with intact data, but a disconnect of who it all belongs to. And institutional to OpenZF are ZVol synthetic block devices, so that you can produce a block device within the file system, anywhere in the file system, provided to the operating system as any traditional block device, and again, under the domain of the system administrator saying, okay, I will determine what we will do with this, be it share it over iSCSI, fiber channel, hand it over to a hypervisor, or you name it. And that gets interesting in the ability to put foreign file systems on top of that block device. So it is quite reasonable to provide that block device to your hypervisor, format it NTFS, and bring all these benefits to that guest operating system. Same for your Linux file system of choice, you name it. And as I mentioned, you can share it as you please. Now, other advantages of OpenZFS, it is open source. There's some argument of the license, but it is absolutely acceptable by a great many parties. It is extremely unique in that it is cross-platform and bi-endian, such that I think we're now seeing, with the increase of ARM64, a renewed sense of, okay, what different architectures do we have server side as opposed to your phone versus your desktop. So the sharing of data in that regard is rather important, and having a file system that will transfer between enterprise machines, I consider a very good thing. I've been using ZFS on my Mac for a good 4 years through various strategies. It's real ZFS. It's on a Macintosh. It's not bootable, but that's just fine for my purposes. And I can interact with other ZFS providers for backup at the block level. So again, extensive fine-grained control at the preferred term is data set for a file system, which in all practicality is a directory from our perspective, but that directory can have a unique block size. It can have unique quotas. It can have unique compression. It can have all the properties that traditionally a full file system would have. So that's desirable. And naturally, ACL differences between, say, Windows guests and Unix guests and all the little subtleties that are often needed to keep services happy. OpenZFS supports hybrid storage quite well, be it flash on the flash in, flash out, so a write log that guarantees that you have the integrity checks but at the performance of your flash device. That's naturally a hot topic here, be it NVDIMMs, be it NVMe. NVDIMMs are quite exciting because they're generally following the limits of memory devices. And in the case of what's called the S-log in OpenZFS, a little bit goes a long way. You take your network traffic and decide how much traffic can pass through there and need to go to disk in that, typically by default, a 5-second window. Do the math, and a few gigabytes is all you'd ever need, but you want it very fast and very durable. And from there, one can have a read cache of various forms, now compressed, to supplant the fact that, well, ZFS will generally make liberal use of your available RAM, though it's controllable, and then push out to flash for frequently read data. And soon that should be persistent in that you power down a server or you boot it back up and you do have a warm read cache. And for some environments that works very well to have, be it all user templates to be available at an instant that people are filling out all day. Even virtual machines benefit from having some common data in a cache. So lots of opportunities there rather than a strict predetermined strategy being handed to you. OpenZFS snapshots are quite unlimited. In high volume, they start listing slowly. That sometimes can push the problem to your user interface on how quickly it responds. However, internally, I've seen people accidentally create 20,000 snapshots, and it was a little slow to list, but the system handled it just quite well. And on several of those previous operating systems I mentioned, 20,000 snapshots would result in a most unpleasant experience, to put it super politely. And again, in such very flexible in that you can do it at the dataset level, the block devices can be snapshotted and sent with efficient deltas to backups of them. And naturally, enough features for 2 books. Some colleagues of mine have produced 2 books on ZFS found at zfsbook.com. Specific to FreeBSD, but the basics apply to any ZFS environment, for the most part, even the Oracle ones, though those have recently received some somewhat negative news. And in practice, OpenSolaris is where what became OpenZFS came from. That has migrated into Illumos in the community, and there are various derivatives on that. I believe OmniOS just became OmniOS Community Edition, and Joyent SmartOS is quite popular as a server-side open source solution to run. But I come from FreeBSD circles, so those have always been open source back to Berkeley when classic BSD was first made its way out there. GNU Linux does have some legal concerns surrounding the use of OpenZFS and the inclusion of an OpenZFS kernel in a ship distribution. The vendors disagree on the risks of that, and some organizations are comfortable with the potential risks and pressing those limits, and some vendors are not comfortable pushing those, and that time will tell how that works out. And naturally, macOS is a nearly tier 1 OpenZFS provider, and I'm running it on this machine right here. So the slides are sitting on an OpenZFS dataset. Also, in practice, as I touched on earlier, having a common file system to your workstations and servers can have its advantages, be it the individual backing up of a workstation to a server, perhaps a 1-disk small store, to a highly redundant server-side store at the block level in a consistent manner. I consider that a very good thing. And naturally, any given data set can be shared out with your protocol of choice, be it SMB, NFS, AFP, FTP. Is anyone using AFS? It's one of those things that's real soon now. For a good decade or so, I get a nod there. It's like, we need better file sharing protocols. Even this long on, we now understand the issues, but I don't see the perfect solutions yet. But again, those block devices can be shared as you please or made available locally to even the host OS or a hypervisor. But there's still a very good use case for a raw disk image sitting on a sophisticated file system. You have all the benefits of checksumming, you have the benefits of compression, you have many benefits, and a user a new administrator who sits down at it says, yes, there's my VMDK for this system, whereas an internal synthesized block device can be a rather opaque construct that they know they're using disk space, but they don't know where it went. So the flexibility is most useful and refreshing, and we can talk hypervisors in the hallway if you like. So unlike a great many file systems over the years that perhaps were paid for, there are no artificial limits on OpenZFS, such that if you have a notebook that supports 3 flash storage devices, you can create an array among those without restrictions. Whereas server-side, a group of students can build a petabyte size array with no restrictions, and I consider that a very good advantage. So in that flexibility, we give users a rather fine-grained and flexible undoability to the user, it's undo, help. I don't know why I have this big red screen that says, hey, give me money. What is a Bitcoin? I don't know. So a lot of this takes homework on the part of the system administrator, but the more communication on, again, what restore points and times the user needs, the better you will deploy this. One interesting thing out of the DPCO is the notion of the right to be forgotten. And things like blockchain are exciting, but having a blockchain that says this is where the user joined the company, this is where they worked, this is where they left, this is where they asked to be forgotten, this is where we got the message from them, please forget me, here's them mentioning the law, forget me, and the whole blockchain describes, their presence through history. Well, you need to go fine-grained to truly be able to remove that person rather than simply document the requests to be removed in your immutable long-term store. So the block storage is quite flexible in providing a golden image block device for perhaps more virtual machines, get it in a master and clone it to others. And while this is about combating ransomware, snapshottable virtual machine images at the block level, be it a file in a data set or a synthesized block device, they're great at mitigating unclean virtual machine shutdown. And talking to clients anecdotally, it's like, well, all the Linux servers came back up, but the Windows machine didn't. Roll it back a few minutes perhaps and try booting it, and generally that will resolve the uncleanliness of the panic they experienced. So, as I touched on with the perfect storm of a holiday, Friday afternoon just before a holiday, do discuss internally among administration and with your users about when to snapshot. Should that be daily, hourly, every 5 minutes? I personally am not impressed with the notion of time-based decisions. I think that following the amount of data written is a really good metric as to when to snapshot, because I call that the recording session problem. If you have a recording studio that's empty for the entire month, short of 3 hours, with 3 amazingly talented musicians in retirement, you've brought them together, there's not a lot of value in snapshotting in the first 5 minutes of that recording, and then a week later, just because your snapshot policy follows that, and then the majority of what they did is not snapshotted, yet you have the infrastructure to do so with. So do think of the scenarios that you may face. Let's see. Running out of space through snapshots is a problem I prefer have over losing history. One can be resolved, the other one cannot be brought back. And naturally think about, should we up the snapshot frequency during business hours? Should it, is there value to certain activities taking place off hours? And that's what we want to have the more granular snapshotting of. So, again, as I put here, usage-driven snapshotting, that's where every megabyte of data may be far more interesting than every 5 minutes or thereabouts, where you have a great many empty snapshots. I'll speed things up. So about the restore points, determine from the system administrator perspective, where do you need to get back to in time, and get feedback from the users. An organization may not want to retain much backup data from an e-discovery perspective, yet users may want the ability to go back a month in time. So bring all those interests to the table and compare them. At the same time, you may have archiving obligations, such that certain information must be kept, and there are just a number of factors there, sometimes at odds with one another, determining how often you snapshot data. And as we get into affordable primary storage, secondary storage, and tertiary storage, do you have a high-performance all-flash primary store that backs up to low and slow spinning disk storage? And can you retain more snapshots on that backup as opposed to the primary? So think about, what works best for you and what does a restoration look like from the low and slow to the primary flash, or do you have two fast primary flash machines that can take over from one another and one be promoted? The flexibility is your friend. Embrace it. And naturally, there is a technology and there's the policy, and often organizations are at the mercy of the technology rather than the policy. So with this flexibility comes the ability to push policy on top of the systems, and a little bit of planning can go a very, very long way. As I touched on, talk to your users about what they realistically need. Some can't survive a 5-minute loss in time. Some can survive daily, you name it. It's entirely up to your organization. Naturally, talk to your lawyers about your legal obligations in retaining data. So again, I find this to be a great motivator to address other issues that have been aggravated by ransomware, but they're still perennial issues. The flexibility, again, gives you more opportunities moving forward. So in practice, show of hands, who's using OpenZFS in one way or another? Very few, I know about one or two of you. So in practice, this may mean a storage OS or raw OS upgrade for you, or the supplanting of your current infrastructure with something that supports OpenZFS. Fortunately, there are many options in that regard. There's not one vendor. It's actually an open source technology that's vendor agnostic. And in the FreeBSD circles, there's FreeNAS, there's QNAP. There are various solutions with hardware built atop those. From Illumos, which is, again, the traditional Open Solaris OS, Synedo and Extentia offer solutions, and I know, I believe both vendors have had talks at various SNE events, and you can catch those. And there are fully supported commercial GNU Linux-based solutions, including Datto. So a lot of choice there. And while each of these comes from a vendor, I can safely say that at least FreeNAS is both fully open source and vendor supported in various ways, and is relabeled by others such that it is a vendor agnostic technology whether they like it or not, because that's just the nature of open source. They took on that challenge, but I would argue when you're in a leadership position, people can copy what you're doing, but that doesn't mean they have your vision or hardware resources or others. So I lose no sleep over that ability, the right to fork, as they call it. So again, my experiences with FreeBSD and FreeNAS, I'm happy to answer direct questions in the hallway. Again, fully open source. In all practicality, open source solutions allow for debugging and support at every level of the stack. And that's increasingly even getting to the BIOS on the hardware. And there are efforts to make that possible. When something breaks, I and others truly need the ability to determine what it is, regardless of the cost of pursuing that, be it on my own time or with a vendor. But I'm sure your experiences vary on how vendors have handled flaws found in their software, and potentially hardware. Open source has a very broad and sometimes efficient, sometimes not so, user feedback loop. Some are very vocal and enthusiastic and may have solutions to the problem they've encountered. And that is invaluable, because if you have a fixed development staff and you have 100 users, 1,000 users, 10,000 users, they're typically very smart users because they're there in the first place. They would have just outsourced all that effort to someone else had they not wanted to get their feet wet. So, and their hands dirty. So I'm very much an open source advocate and can give you examples of where that's really worked from a vendor perspective, not from a strictly community perspective. And there's a very strong culture of vendor, and I should throw in academia and individual contribution. The software out of Berkeley has shown up in a great many places over the decades and gave us the internet, and that's thanks to students, DARPA, companies, individuals, you name it. And if you caught my last talk, I demonstrated how there are many opportunities with SNIA. There are a Venn diagram of SNIA and open standards and open source, and an underexplored sweet spot in the center of, for example, NDMP efforts from SNIA, where it's vendor-provided open source software under permissive license that implements a standard. Great! That is what I want to see, and that's where I've been working in that space. So that is very familiar to me. So regardless of the platform you choose, always establish and maintain redundancy. Various solutions will allow you to do stupid things such as not maintain redundancy and not warn you of it. So do understand how the underlying system works. And fortunately, OpenZFS has a number of opportunities to have, be it mirrored stripes for performance, be it RAID Z, which is a distributed parity strategy, and the ability to combine those in various ways and have up to 3 disks of RAID 7, if you will, hypothetically, of the ability for 3 disks to fail out of a given VDEV is a proper term, but a given array. And that technology, again, can be driven by your policy rather than it driving your policy. Block devices can be used sparingly or as just the primary store provided by an OpenZFS solution. The policy for snapshots is very important. Does it follow business hours? Does it follow data transferred? You name it. There's a lot of flexibility there. And naturally, nearly every storage vendor there assumes that you're sharing that data over a network protocol to users. So there's a lot of flexibility there, though. There are very much users putting databases on top of ZFS on a dedicated system, and it's, again, very flexible. In OpenZFS terminology, a scrub is a periodic validation of all snapshots. Once that completes, you know for a fact that your data is without or with some form of bit rot, but if there is redundancy, it will simply replace that be it failed block or otherwise. Do understand your hardware, do watch your smart tests. You need to understand your whole storage stack, but you can understand your whole storage stack, which is a really good step 1 in understanding your storage stack. If it's open source and you can work your way up from the host hardware, its controller, the storage disks or flash devices, or you name it, the partitioning, the file system on top of that, you are both in control and able to diagnose, for the most part, that entire stack. And I find that a very empowering fact. Do replace your disks as they fail, that's quite obvious. And I encourage users to always determine the expected performance of their system. There's rather good transparency on an open software stack, be it from at the tracing level with dtrace, which is a classic, also OpenSolaris provided tracing system, to simple disk monitoring. And if the better the sense you have of your expected performance, the better you will recognize degraded performance. And users may be first to notify you, but ideally you'll have a sense before they even get a sense of what's going wrong. So in that regard, communication comes first. That's between administrators and users, and administrators and management, legal department, of what we have to deliver, because again, in this flexibility, you have more opportunities than most solutions will provide. That communication can reduce recovery time. If people at both the user end and the administrator end know what to do when a certain scenario is encountered, such as a ransomware attack, the more quickly you can resolve that. And by doing so, naturally, if that's caught early on, you can mitigate the spread of attacks. And lessons learned will hopefully prevent future attacks. So education, very important. On a Friday, do not click your random email. Let's always be cautious of that. Just go home early. Don't go down that road. And the more educated your users are, the better. If they know what activity, be it a slowdown or otherwise, is suspicious, If you see something, say something. So, infected systems will reinfect. User data comes in all shapes and sizes. Be aware of what might be a database, what might be Office documents, what might be shared documents and impact other users. Very important. Don't hide about what's impacted. Just be upfront about what's been attacked and what's no longer accessible to the organization thanks to the attack. As I mentioned earlier, with the ability to, for lack of a better term, fork any point in time to a writable point in time to a preserved point in time for forensics purposes. Decide when you want to do that, when not. That hitting the rollback button is real easy, but you might lose user changes that might be recoverable despite it being under an attack. And, typo there. Always keep in mind of what is your most critical data and learn from every experience. Under the hood, for those who haven't touched ZFS in practice, this simple command, the list would list the snapshots, and I have an example of a snapshot on September 10th and a new snapshot on the 11th, the ability to clone that snapshot to a recovery point if you were happen to be attacked at that point, and then the ability to roll back the original to the original point in time. It uses a very human-friendly syntax. Learn the verbs, and they will generally work in each context. I've got about 5 minutes left for questions, but I will be here through Wednesday noon. I'm more than happy to talk to you in the hallway if you have any questions about any of this and how it can help you. Yes, sir.
Michael, is the concept of snapshot being used for mitigating ransomware, if that's the only solution? I'm sure ransomware has become smarter by day.
Every day.
Like for example, the one that we just got hit by, the unauthorized thing. So it is aware of the fact that if I'm using ZFS and it's going to take snapshots, it gains the right privileges to go back and delete the snapshots. Okay, I mean, they get smarter too. So what if there is a situation where the ransomware is sitting there for months together, years together, it's already corrupted your snapshots, it's there in your snapshots. You restore it back and you're going to have that, again, it's dormant. It's not that it's going to be active. So is there any other way other than snapshots that you thought about, that you've come across to mitigate ransomware?
Okay, the question is, what do we do about dormant ransomware? And that is a very good point, because the more clever the attackers become, they can infect and wait, and indeed consciously wait through that recovery point window. So I'll say this. I've been very active with hypervisors. And in storage, I think they're becoming quite interesting in 3 key points. I give a talk Thursday on one of these points, and there's a different of those 3 points, fortunately. One is adding features to a storage solution, such as many are doing, and we even get into hyperconvergence. The other is chasing regressions. But the third is the validation of backups. Now, when you have online storage, as is typically provided by OpenZFS, your backups and your primary are all online. They can be brought up, especially in situations where you have a database on a virtual machine on your storage system. They can be brought up in read-only mode and interrogated by the hypervisor. Say, okay, does this database import? That's a very key point, because the database people will let you know that, wow, we've had lots of backups, but didn't realize that they're all dumped in an unclean state, and we are bitten by that. So the ability to use a synthetic environment to run through your backups, potentially running a Windows operating system, for example, which is the #1 target, on your backups in a routine read-only or cloned manner that exercises every corner of your data and applications may have a valid use case, because you don't know where that's hiding, and the more effort you can spend just considering the attack vectors by looking for them through your existing data may give you some solutions. But again, because they're relying on write access, it is indeed a challenging arms race. I hope that answers your question as one possible answer in what is indeed a challenge. I'm not saying this is easy. I'm not saying this is a universal solution. It's a very good point. Any others? Thank you so much. I'm more than happy to talk to you in the hallway, and enjoy the show.